I wanted to make a quick video on how I personally study physics and what I think is a really good way to do so. Normally, when I teach this, I use an analogy of tennis, but I'm going to use one with chess because I'm working on an iPad. So here's the idea. How do chess players get better at their game? Obviously, the best ones will be studying, doing puzzles, and playing the game nonstop. But maybe you don't have time to play thousands and thousands of games. So what's one good way you can try to get better? So one thing that's recommended to like 1,000 level players is to go through books and study a lot of puzzles. So simple enough. Let's just do a puzzle together right now. So this is white to move and win in one, with a pretty gnarly looking board. And maybe if you know some chess, the first thing you're going to think is, well, what's checkmate in one? I have this rook right here. I'm going to move it to the back rank right here. And the rook there will give me a checkmate. So now I've solved one puzzle. In theory, if I ever see this exact board again, I should never get this wrong. But obviously, if you've played any chess, you know that there's like tons of configurations of the board. So studying every single one isn't feasible. But there's a few cases that are quite similar. So right now, like pay attention to this pawn position over here. Let's look at this next puzzle. Here's another puzzle where all that's changed is if you notice this pawn positioning, we have one pawn over here that's moved. This puzzle is still white to move and win in one. So again, with the rook being able to sort of block off a line, I see this rook here. I move it to the back rank and I get my checkmate. So obviously I don't need to study every single case of every single chessboard. The way chess players prevent themselves from studying billions of puzzles is you learn how to apply the concept. So what's the concept here? I would have studied that first chess puzzle and said to myself, the idea here is if I see a king with no escape route, then the first thing I can look for is, do I have a back rank mate with my rook? Because if I put my rook on that X, the king can't go anywhere, and I'll have a checkmate. So now with this idea, we try to extend it to other variants and other puzzle ideas. So if you're in my recitation and also at the review session, you've heard me say this a lot. What are the puzzle or what are the problem variants? What are the ideas? So let's look at this board right here. Very different. Now the king no longer is blocked in by pawns, but the idea is the same. I have another situation because of my rook here. I've blocked off this entire ring. So nothing here is a place where the king can move. This is again a maiden one. So I see the king has nowhere to move forward. What should I look for? Here's my rook. If I bring it down here, I have a checkmate. So from the one puzzle I did before, I've already solved two other puzzles with the same exact idea. When might this fail? I should start looking at variants like that. So here's the same puzzle as from before with a few changes in the pawn structure here, but the main difference being this pawn that is moved up here. So I stare at this, and the first thing I notice is if I try to move my rook at the same position, this is no longer a mate, because now the opposing king is able to move over here. So how would a chess player synthesize this? The first thing I think is if the king is in the back rank, look for a rook back rank check. This applies to the first three boards that we looked at. However, the main pitfall, you also need to look for escape routes. In this fourth board here, we saw that the king can move somewhere else and escape from the checkmate. So this is the principle that I'm going to go off. The example that I usually use with tennis is the idea that a tennis player would have to work on their forehand and backhand and serve in a vacuum. And the way you learn how to apply this is by playing matches and thinking about scenarios in which where you'd want to hit the ball. So now let's apply this to physics. I'll probably have a timestamp here for anyone who wants to skip the chess analogy, but we're going to go with the same idea. The physics study plan is we never want to get the same problem wrong twice. So here's the idea. First, we're going to find a problem and work through it carefully. What this means is we're going to take a problem from Halliday, from Wiley Plus, or from anywhere we've seen, and we're going to work through it step by step. There's going to be times when we get stuck on parts of the problem, and there, instead of looking up the full solution, what we're going to do is either go to Halliday for an example, go to our notes for a formula, or go to maybe just one line in the solution to figure out how to get over this bump. Once we're finished with that, we're going to check and synthesize our solution. So this is the point where you're going to compare your answer to the actual solution, figure out where you deviated or where you did things incorrectly, or maybe where your solution was slightly worse or even better. From there, you want to write maybe in the margin, and I'll show you how to do this. Write down, what did you learn at each step? How did you know what to do? And this is also the place where you want to start synthesizing key pitfalls. So is there a mistake that you made? Why did you make it? Are there things that you should be looking out for? The thing we want to do after that is do a short reflection. So normally I do this in my head, but for the case of this example, I'll even write it down, like the main ideas it took away. And once you did that, if you did steps 1 through 3 correctly, you should be able to close your textbook and just do the problem again from memory, essentially. You probably will memorize everything perfectly, but if you've done the synthesis properly, you should know what steps to take. The one caveat I'm going to say here is you obviously still need to do more problems. When you reach more advanced physics classes, a lot of students will only do 1 or 2 problems per subject, and that is enough to give them the key ideas. But then you still need to do more problems after that in order to sort of flex those muscles. So for example, like obviously if you hit one perfect forehand in tennis, you might know how to hit that perfect forehand, but you still need to practice it. You can't just rely on your muscle memory to take over if you've only done it one time. So now I have an example problem. It's from 1400 mechanics. So here's the following problem. A ball is launched upward with a velocity v, it's pointing upward, a height h above the ground, and this ball has a mass m. And the question is, what is the velocity right before the ball hits the ground? So I'm seeing this on my homework. The first thing I'm going to do, I remember from lecture that we were told that with these sorts of problems, we should use work energy. So what I'm going to do is write the following expression that I remember. One thing I remember from this too is if we set a reference to 0, and since the velocity, we're looking for the velocity right before it hits the ground, this final potential energy is 0. But I've forgotten what the formula for kinetic energy is. So this is what I would think out loud. I'm just going to write it so you can see it. So maybe I forgot kinetic energy. What I'm going to do is go to my notes and find that Ke is equal to 1/2 mv squared. So now that I know that, I can keep solving the problem. So my initial velocity is v. My initial potential energy is mgh, and this is equal to 1/2 m, the final velocity squared. The m's cancel out. I'm going to move the 2 in front here. So I've just multiplied everything by 2. Vf is equal to v squared plus gh, 2gh. Sorry, vf squared. So therefore, the magnitude is equal to v squared plus 2gh. So therefore, as a vector, it's pointing in the minus y hat direction. And this should be my final answer. So now that we finished this, obviously we got the problem wrong. What you should do is look at the solutions and compare where you made the mistakes. And then this is the same process that will apply. I'll do all my annotations in orange. So first, I said use work energy. How did I know to do that? So when I see velocities, heights, and finding final velocities, I should always try work energy. So why I'm writing this here, because I'm trying to remember, how did I know to make this my first step? How am I going to know to do this on other problems? It's because when the problem was presented to me, I saw an initial velocity, I saw an initial height, and I saw that the question asked me for a final velocity. So this is how I'm synthesizing the following. How did I know that PE was final was 0? I can set my reference to get PE is equal to 0. P final equal to 0. I forgot the kinetic energy when I was doing this problem. How am I going to make sure I never forget it again? Remember that kinetic energy is proportional to velocity squared. I'm writing it this way because I want to remind myself that the way I'm going to remember the kinetic energy is the fact that it's proportional to how fast something is moving. This step here is algebra, and you notice that when I actually did this one down here, I almost fumbled the 2. So I'm gonna write like, be careful. And maybe just like math. It turns out a lot of people, when they make math mistakes, it's sort of the same ones. So it's good to know that. And then I found the final velocity as a magnitude. How did I know the vector direction? So I remember the ball was going downward. And then once I finish this, what would I think to myself for the synthesis? I'd probably think the following. When presented with a projectile type problem, if energy is conserved or work is known, try work energy theorems. And this is my main takeaway from the problem. Now, how do you build connections to other ones? This is what I would, well, first I would tell you to redo the problem. Just you close this file and do it again from scratch. But I'm going to skip that step because it's sort of redundant for the case of the video, but you should definitely do it. I'm going to start thinking about variance now. So I should start questioning, what can I change in this problem? The first thing I can think of is, well, my initial velocity in this problem pointed upward. What if I made it go downward? What would change? I would ask myself that. 2, obviously everything isn't just straight up and down. What would happen if I put a wall here and I have this initial problem that I had before? And now I'm going to tilt it. So now suddenly I have a ball on a ramp with maybe some initial velocity going up the hill. How does the problem change there? And if you're looking at 2, this might remind you of something similar. What happens if I have a half pipe? I have a ball right here. Maybe it's moving down now. What's the final velocity at the bottom? I would ask myself that question. And then I would think about what other energies are there? What would happen if I added in friction? Is this something that's feasible in the class? Is it within the scope of the class? Air resistance? Maybe it is, maybe it isn't. You might also ask yourself, what are the types of energies are there? So maybe the 5th variant I can think of is, what if I made the same loop problem and I made this a disk with some angular, like some spinning, basically. How would this change the problem? Yeah. So this is how I would study. So just to recap in words, you basically solve the problem normally as you would. Anytime you get stuck, instead of looking at the full solution, you look just at the next step or try to get yourself unstuck by looking at your notes. From there, once you finish, go through your solution carefully, make sure it's correct. And once it is, synthesize every single step that you're doing. Make sure you're learning about at every step. Why did you know what to do? How did you know what to do? And why did it work? Once you're done with that, do a quick reflection, then close your book and do the problem again immediately. Make sure that your synthesis was solid. Then after that, you don't need to solve all the variants, but you should start thinking about other scenarios that can have a similar problem. This way, when you take an exam and even do homework, when you see one of these problems show up on your homework, you're already thinking, in my problem vocabulary, I have this problem of a ball being thrown upward with energy, given some initial velocity and some given height. I'm going to use these same ideas in all these other problems. And then obviously, if you're studying really hard for an exam, you would actually do these problems out. Hopefully this helps you build some sort of game plan of how to study for future exams.